Hi class, let's take a look at example 5. And example 5 deals with the following. So you're going to have some equations in some regions on the plane that don't require punching coordinate points. They're basically are circles or some sort of a line. They may require for us to go back to rectangular depending on what are the instructions. In this case, I just want us to graph them. Now take a look at the first equation. This is technically r is equal to 1, and if you have r is equal to 1, you could technically square here both sides of the equation and then end up with r squared is equal to 1. And then r squared, if you go back to the actual equations or relationships that we had, you're going to have that r squared represents x squared plus y squared. So in this case, you could do the substitution and then technically rewrite that x squared plus y squared is equal to 1. And this is because r squared is equal to x squared plus y squared. In this case, I just wanted to emphasize that r is equal to 1 represents a circle of radius 1. So not to scale, this is 1. And then I'm just going to try to draw a circle as best as I can. As long as it appears to be a circle, that would be fine. So we're talking about this, not the best circle, but that's what we're talking about for this actual one. I think I'm making it worse. Okay, and this represents technically r is equal to 1. Or you can express it as x squared plus y squared is equal to 1, or a circle of radius 1. Now, take a look at problem B, and it said r is less than or equal to 1. So in this case, we already know that r is equal to 1 represents a circle of radius 1. So in this case, this is going to be our circle. The region that they're talking about is less than or equal to 1. So this one we're going to be shading, and it's just basically all coordinate points inside of the circle. That would be it for part B. So problem A, just a circle, radius 1. B, it's an actual inequality, everything inside of the circle. Let's take a look at problem C. In problem C, we're still talking about a circle, but we're not going to actually shade the entire circle. We're only looking at pieces. So we're looking at this portion here. Okay. Now, they're only interested on the angle being from pi to 2 pi. So technically, it's going to be this lower portion here. So quadrant 3 and 4. That's actually it for this one. I'm careful because a couple of these may not be actually including the boundaries or basically the entire circle. So you just have to keep track of what they're asking. On all of these, they're actually saying that it's equal or less than or equal, but you could have one of those. Okay, so let's take a look at problem D. And problem D, it's not easy to identify because you just have, well, the values of the theta is equal to pi over 4. Now, the trick on this one is to basically use one of the equations above here and then make it look like, well, express it in one of these equations. And the closest one is basically that the tangent of theta is equal to y over x. So what I'm going to do on that last problem, I'm going to evaluate the tangent on both sides of the equation. So in this case, we're actually going to have, well, let me rewrite it since it's not going to fit. So we still have theta is equal to pi over 4. So we're evaluating the tangent of theta and the tangent of pi over 4. And then I'm going to rewrite the equation so that we technically have that the tangent of theta is equal to the actual tangent of pi over 4. And by the identity, this is technically y over x. And this is technically since the tangent of theta is equal to y over x. So that's the formula that I'm using. And this is technically done. At this point, we can rewrite it. And we're just going to have that y over x is equal to the tangent of pi over 4, or the sine over cosine of pi over 4, which you're going to end up with y over x is equal to 1, or y is equal to x. This is what we're obtaining after we multiply technically times x and times x, and after we evaluate the sine of pi over 4 over the cosine of pi over 4. So this particular equation happens to be just a line. So in this case, let me do it in green. So 1, 1, this is our actual equation. This represents theta is equal to pi over 4.